Okay, I think there's probably some question over price elasticity versus slope, and I had an email about it, and I want to go ahead and put it online so you guys can see that. And working on your packet on activity 17, we know price elasticity, what it's measuring is when there's a change in price, what is the corresponding change in demand or supply. So how elastic or responsive is a quantity change to a change in price. So we know that this is our formula. Price elasticity is essentially the percent change in quantity over the percent change in price. And we write that out Q sub 1 minus Q sub 2 over Q sub 2 plus Q sub 1 divided by 2 all over P sub 2 minus P sub 1 over P sub 2 plus P sub 1 divided by 2, which is review for you. And so we'll do one of the questions. I guess it's question number 3. They're saying what's the elasticity for between $1 and $2. So if we wanted to do that, we're looking at $2, it's 160 quantity, and the quantity demanded is 180 for $1. So it'd be 180 over 160. I'm sorry. It'd be 180 minus 160 all over 180 plus 160 divided by 2 over 2 minus 1 over 2 plus 1 divided by 2. Give it a marker. And this would be, 20 over 140 divided by, this would be 140 divided by 2 over 70, right? I'm sorry, 170. And then all over 1 over 1.5, which is 0.18, or sorry, 0.12, 0.12 all over 0.67, and that equals 0.18, and that is inelastic, right? So the response and change between 1 and 2 elicits not a huge change, so it's inelastic. So how does that also fit in with slope, right? And what they want you to do is to realize that you can have a constant slope. For instance, they want you to look at the elasticity of price between 5 and 6. So between 5 and 6, if you work it out, you'll see that between 1 and 2 is inelastic. Between 5 and 6, it end up being elastic, right? And you can do the math on that. With the change between 5 and 6 and 80 and 100, you can do the math following this formula and find that it's elastic because 1.22 is the number. But what they want you to see is that this line is a constantly sloping line. And on a constantly sloping line, you can have one point in the graph that can be inelastic and a different point that can be elastic. And they want you to mathematically understand that by doing some slope equations to see that a constantly sloping curve can be at different times elastic and inelastic. So they want you to look at slope. And your formula for slope is just rise over run, right? So essentially, rise is up the y-axis and run is on the x-axis. So a change in p, or a change in the y-axis, over a change in q, or a change in the x-axis, right? And a change in just means subtracting. So we can do this same thing here. So this is between $2 to $1, right? And then between 5 and 6, we'll see what happens. So rise over run. So for $1, it'd be a change in price is 2 minus 1 all over change in quantity is 180 minus 160, and that's 1 over 20, and that equals 0.05. All right, and that's between 2 and 1. Well, let's look at it between 6 and 5, or 5 and 6. You have 6 minus 5 all over 100 minus 80, and that equals 1 over 20, which equals 0.05. So what we see is the slope is constant on this graph, but the elasticity can still change, right? And we've proven that using this analysis. So I hope that answers it. If you have questions, let me know. Email me. But that's essentially, and I hope you do that in your math class, rise over run just gives you the slope of a line, and that should be able to tell you. So that is slope versus elasticity.